Alright, so we're going to start chapter 4 with 4.1 radian and degree measure. And in this chapter we're talking about angles, and we're talking about most particularly how long it takes an angle to go all the way around, starting from the positive x-axis and swinging all the way around back to where we started. And so that's what we're going to be talking about in this section. So when we talked about angles, a couple things we want to get started. When we start an angle, the starting side is called the initial side, and then the finishing side is called the terminal side. And so when we talk about an angle in terms of the unit circle or the coordinate plane, the angle, which we're going to use this symbol, theta. All right. We're always going to say that the initial side starts on the positive x-axis. All right. So if we're moving in the counterclockwise direction, we're going to call that a positive angle, and if we're going the opposite direction, we're going to call that a negative angle. And then the last thing on this slide is talking about coterminal angles. A coterminal angle means different angles that end up in the same place. For instance, this one here, I'm going to call that 215 degrees. Looks about right. If we spun here, that'd be 180 degrees. Now this one, if we spun the opposite direction, we would go negative 90 plus another 45, negative 135 degrees. Those two angles, 215 and 135 negative, are coterminal angles because we end up at the same terminal side in the same location. All right, so if we notice here, this positive angle going all the way around the circle is the same as just going the short distance and not going around the circle. So alpha and beta would be the coterminal angles. Not the same angle, one's big and one's small, but they end in the same spot, so coterminal. All right, so let's talk about radian measure first. A radian is the angle necessary so that the S, which is an arc length, so some curve of a circle, divided by the radius of that circle. If those two lengths are the same, then we have 1 radian. So a radian is defined as the angle necessary so that the arc length you get is the exact same length as the radius. So we don't typically use a single radian that much. What we end up using is in terms of pi. If we go all the way around the circle, which we'll look down here, we end up with 2 pi, which is what this is saying down here. A complete circle is 2 pi radians. So we can split up our circle into some pretty common elements. Half a circle would be pi. A quarter circle would be pi over 2. And then these other common intervals, pi over 6 is a third of the first quadrant. Pi over 4 is half the first quadrant, cutting it in half. And then pi over 3 is a third, that's going to be 2/3 of quadrant 1. And so pi over 3, we could use 3 of them to do a half circle. All right? So moving on, we're going to talk about quadrants. And so quadrants, typically we're going to say if if your terminal side ends in one of the quadrants, then we're just going to say that theta lies in that quadrant. So if your angle is between 0 and pi over 2, you're in quadrant 1, and so on and so forth as you move around the quadrants. All right, let's take a look at our first example here. We want to sketch and find some coterminal angles. So for the positive angle, 13 pi over 6, subtract 2 pi to obtain a coterminal angle. All right, well, let's look at what the sketch would look like first. 13 pi over 6, we're going to spin all the way around. That's 2 pi. And then another pi over 6. So our ray, our terminal side would look like that. This is an additional pi over 6. All right, and so we can see that the coterminal angle is just, what if we just started from the initial side and just went that pi over 6? Didn't have to go all the way around the circle, just go that short distance of pi over 6. All right, so 3 pi over 4, where would that be? Pi over 4 is half a quadrant, so we want 3 of those. So 1, 2, and 3. And there would be your final side. All right, and then to go the opposite direction, we could go negative. Remember that half a quadrant is 1 pi over 4. So there's a quarter, 2 quarters, 3 quarters, 4 quarters, and 5 quarters. Going the opposite direction, we end up in the exact same spot. And so we'll look at the last one here, negative 2 pi over 3. So 1 pi, negative 2 pi over 3, if we go that way, is the exact same thing as spinning around the opposite side. 1 pi, 2 pi, 3 pi, and 4 pi. We go the other way. So you'll notice to find a coterminal angle, you can either add or subtract 2 pi to an angle, and you're going to get a coterminal angle, because coterminal means go around the whole circle again, 2 pi. All right, so let's try 27 A and B. Let's find 2 coterminal angles, one positive and one negative for each one. So our first angle is pi over 6. All right, so what we can do is we can add 2 pi, and we can also subtract 2 pi from each of these. So this is pi over 6 plus, let's get a common denominator here, 12 pi over 6. So we get 13 pi over 6, sorry. 13 pi over 6. And then here we've got pi over 6 minus 12 pi over 6. So we'll end up with negative 11 pi over 6. Let's go ahead and do the same thing for example B, 5 pi over 6 plus 2 pi, 5 pi over 6 minus 2 pi. So let's again call it 12 pi over 6. And so here we'll end up with 17 pi over 6. And another coterminal angle would be negative 7 pi over 6.